Okay, I've given a short introduction on how the inverter does the automatic transfer. It does do automatic transfer for us, but I will still go in and insist or highly recommend that you install a manual transfer switch, a bypass switch, you can call it whatever you like. And the reasons for that is if anything goes wrong with the inverter, if you turn off the batteries and the solar, if anything goes wrong on the solar or the batteries, the inverter could go into an alarm, and even if it's got grid feeding it, it will turn off your backup circuits, and that will leave the customer or the installation dead and not powered, even though you got grid voltages. So a bypass switch is just something that the customer can go on Christmas Day or whatever and just manually change over and bypass the inverter system, giving their critical circuits voltages and power again. And then there's another way, which I'm going to show you today, is how to set up this reasonably priced automatic transfer switch. This is actually an automatic transfer switch. It's got pins on the top here which do the transfer for you. How to set that transfer switch up so that if the grid fails, it will transfer the circuit onto the backup of the inverter, allowing a more powerful backup system than the inverter rated power. So this is a 125 amp transfer switch. The inverters are only 16 amps each, so they can only do 32 amps on each phase. So effectively, I could have a much more powerful house or office block or commercial system on this transfer switch because I've got it. And that's really nice. And then the other major advantage of setting it up in this topology is that if you have any maintenance on the inverter or the inverter randomly fails, you would get it automatically transferring back to the grid or remaining on the grid if it is set up like that, and keeping the house circuits or office circuits working and operational.